Okay, in our next video, we're going to be talking about the law of cosines. And you might be wondering, okay, why do we need a law of sines and a law of cosines? Well, when the law of sines doesn't work, we can always resort to this law of cosines. It says the law of cosines can be used to find a side or an angle given two sides and the included angle, which would be a side angle side case. So if you have like A and B and maybe angle C, you can use it to find the other pieces. Or if you're given all three sides, a side case, you can use it in that scenario as well. Reminder that angle C and side C are always across from each other, the same as angle A and side A, and angle B and side B as well. So just make sure that you remember that. Now here is the actual law of cosines and what it states. Law of cosines starts out a lot like the Pythagorean theorem. It says that a squared equals b squared plus c squared. So it kind of looks like the Pythagorean theorem, but it goes a little bit further than that. Minus 2 times b times c times the cosine of a. So that's one of the three laws of cosines. However, there's two more, but I want to point out that honestly, they're the exact same formulas. If you were to rearrange this A, B, and C, you get the exact same formula. So the second formula says b squared is equal to a squared plus c squared. So notice all we've done here is we flip-flopped our a's and b's. So you have minus 2ac times the cosine of b. Then our last formula says that c squared equals a squared plus b squared. So all you've done there is you've switched your b's and c's. So minus 2ab times the cosine of c. So there's your three laws of cosines. Now let's actually look at some problems and let's apply those three laws. So on this first problem, I want to point out first off that there's no A, B's, and C's. And I like the fact that they left these blank because that'll just go to show you that honestly it doesn't matter which one of these formulas that you use. If this were angle A, for instance, I would have to use my first formula because my first formula is the one that involves angle A. And you would have the fact that you're given angle A, but you're looking for side A. So you'd be looking for little a given the larger A there. B and C would be these other two sides. It would not matter which was which. So you could let this be B and you could let this C be C or vice versa. Or what if this was angle B and this was A and C? Then you would be using the second formula because it's the one that involves angle B. And honestly, the same numbers would get plugged into the exact same places. So again, it doesn't matter which formula you use, as long as it all revolves around what you call this angle. So what I'm going to do, we'll let this be our angle A. And again, these don't matter. It's B and C. We'll put it like that. So plugging this into our first formula gives us a squared equals, I'm going to write the formula down, b squared plus c squared minus 2bc times the cosine of a. That's cosine right there. So therefore, small a is x, so we have x squared equals, little b is 23 squared plus little c is 9 squared minus 2 times 23 times 9 times the cosine of 71. So now, honestly, it is all calculator work. So you're going to type this in, 23, just type it in from left to right. And you're going to get x squared, and I want you to try that just to make sure that you understand how to type that in. But once you type it in, you're going to get x squared equals 475.2148. But just understand, that's what you get when you type this in, but you are not finished because it says that x squared is equal to that. So you do have the final step of you must, in order to get a squared, we're going to take the square root. Now, reminder, you really need to put a plus minus here, but since we're talking about a side length of a triangle, we know that that can be negative. So the square root of 475.2148 is about 21 point, let me look one more time, I think. Yes, it's 21.8. And that is approximate. And you can check that if If this is 9 and 23, notice that if this is drawn to scale, that seems about right because it looks like this is the biggest angle, so therefore that should be across from the largest side. 71 degrees, that's a pretty good size angle. That nearly looks like a right angle, right? Nearly looks like a 90-degree angle, so that makes this angle right here very small across from 9. So that seems very reasonable there. Okay, next problem. Again, it doesn't matter which one you plug it into. Um, Honestly, every time that you work one of these problems, you could let this be A, the angle that you're given, and that way you have to know one formula. So you have A squared. So let's actually, instead of copying it down, I'll just refer to up here. You have A squared, which will be your X value. So X squared equals B squared, which would be 17, plus C squared, which would be 15. Let me make that a little bit better. So 15 squared minus 2 times 17 times 15 times the cosine of A, which is 39 degrees. Again, this is simple order of operation. I do want to point out for future problems that there are 3 terms. 17 squared is a single term, 15 squared is a term, minus all of this is a single term. So as you type this in, using order of operations, you would square 17, square 15, multiply all this together, and then you would take those answers, add the first 2, and subtract the last. That gives you a value of about x squared equals 117.6556. To undo a square, we're going to square root, so we now have to square root that value. And that's going to tell you that x is, and I should have put on that last one, x is about 10.8. Now, something else I want to point out on this problem, since we got our 10.8 there, what if now we wanted to find angle B? What we can now do, since we know that this is about 10.8, we could use the law of sines and say the sine of A, which is 39, over 10.8 equals the sine of angle B over 17. And you could actually use the law of sines. There is one problem with that, though. 10.8 is a rounded answer. So if you're going to use 10.8 in a problem such as this to find a missing angle, what I would do is I would use a more exact answer. I would use maybe 4 to 5 decimals just to make sure that this is going to be more exact whenever you work that problem out. Okay, the next problem, I want to point out that on this one, notice that they give you angle B. So they don't draw the triangle for you. They say that angle B, let me just draw one here. I've got angle A, B, and C. Angle B is 106 degrees. AB is 10 and BC is 7, and they want you to find AC. Now watch this. I told you that you can use any of the 3 formulas that you wanted to, but there's an issue here. You're given angle B. Well, honestly, now that you've got this thing labeled, if you wanted to, you could erase these letters and you could let this be angle A and let this be B and C, and you could use that exact same formula we've been using, but we will go ahead and do it the way that they've got it labeled here, A, B, and C. And since we have angle B, we're now going to use B squared equals A squared plus C squared minus 2AC times the cosine of B. And you notice that that one does involve angle B. So little b is going to be our x, so x squared equals 7 squared plus 10 squared minus 2 times 7 times 10 times the cosine of 106. All of this gets typed in, and that gives us that x squared is equal to 187.5892. And then the last step, to get rid of a square, we simply square root that. And we get about 13.7 for our x value. That's a 7. Okay, last thing we're going to do with this is, what if we're missing angles? How do we work it if we're missing angles? In the same way that you remember with law of sines that you had that last step of finding inverse sine, well, since you're looking for an angle here and we're using the law of cosines, just keep in mind, hey, I bet I'm going to do inverse cosine. I'll have to use that in our last step. We're going to let and again, it doesn't matter which is which, but we'll use our first formula. We'll let that be A, this be B, and this be C. It doesn't matter. So I have now A squared equals B squared plus C squared minus 2BC times the cosine of A. So we're looking for our A value here. This one's going to be slightly different the way we work this. And I'm going to show you a couple of different scenarios of what you can do here. So small a is 8. And you already noticed that that's not our unknown anymore. So we're going to have actually an equation here to solve. 8 squared equals 10 squared plus 11 squared minus 2 times 10 times 11 times the cosine of A. Now here, first off, this is the main mistake that people make. They'll jump in head first and they'll just type all this right here into their calculator. You can't do that. That's actually 3 different terms. Those are not, these two are like terms, and that would be fine to do there, but this is not a like term. These 3 values over here have a cosine attached to it. So you can clean these other ones up individually if you would like to. You could say 64 equals 100 plus 121 minus, and you can go ahead and multiply these, and I believe that gives us 220 cosine A. However, again, notice that these 3 terms are not like terms. We can combine these two, but this one has a cosine attached to it. So if you would like to, you can say that 100 plus 121 is 221. That's fine. Minus 220 cosine of A. Okay, now this is a basic equation now. Imagine this problem being 64 equals 221 minus 220x. Because basically that's what you have. You have an unknown right here. We've got to isolate that unknown. Well, how would you isolate that? You would move the 221 over, and then since these are being multiplied, you'd divide by it. And we're going to do the exact same thing with this problem. Let me erase that. We are going to, next step, move that 221 over by subtracting. And that gives you negative 157 equals negative 220 cosine of A. To get rid of the negative 220, we're going to divide by it. And that gives me the cosine of A is equal to, let me clean that up just a little bit, doesn't really look like an equal sign. Cosine of A is equal to about 0.714. And then notice what we're going to do next. In order to get A by itself, get rid of the cosine by taking the inverse cosine. So we're going to do the inverse cosine, and that there's a decimal there. The inverse cosine of 0.714. And that tells me that A is about 44.5 degrees. And again, that's one method of working it. And I want to go ahead and erase some of this, and I want to show you something else that you can do. And this is perfectly legal, and it's going to make things a little bit faster if you want to do it this way. I want you to be able to plug into those formulas and know and understand how to use those formulas, because these next formulas, if you're going to use them, you kind of need to commit them to memory. But look, if you've got this formula here, A squared equals B squared plus C squared minus 2BC. A reminder that I told you that there's 3 terms over here, and this is why I told you that. You can actually solve the equation before you plug stuff in. So I can take B squared and C squared, and hey, let's move those guys on the left side. And now I have my A squared. When you move B squared over, it becomes a minus B squared. When you move C squared over, it becomes a minus C squared. And that's equal to negative 2BC times the cosine of A. Since these are being multiplied, I can mark these out and actually divide by them. Actually, let me go ahead and just erase them to make it look a little bit better. So it equals the cosine of A. And you actually have a new formula. Let me move my cosine over here. So if you wanted to, look, I've got cosine of A solved now. you could take A, B, and C, which are now, let's see, what was it, 8, 10, and 11, and plug it into that. 8 squared minus 10 squared minus 11 squared. And you could type that into your calculator. And on bottom, you have negative 2 times 10 times 11. And you type that into your calculator, divide the two, and guess what? You get that 0.714 going straight to it instead of having to solve an equation. But I am going to actually use the equation on the next few just to get you used to it. So here will be my A value on my next one, and it doesn't matter which one B and C are, but we have A squared. So I have 16 squared equals B squared, which is 5 squared, plus C squared, which is 13 squared, minus 2 times, and I always remember the numbers that come next to this 2 are these two numbers. So 2 times 5 times 13, that's how I remember the formula, times the cosine of your angle, which is x. To solve this, and now I'm going to do it, all these steps without a calculator to begin with, to show you that you can just do it like this as well. Instead of plugging all this stuff in, I could take my 16 squared and I could go ahead and move these two terms over. So you now have 16 squared minus 5 squared minus 13 squared equals negative 2 times 5 times 13 times the cosine of x. Since these are being multiplied, I can mark these out by dividing by them. Negative 2 times 5 times 13. So that gives me now the cosine of x is equal to negative 0.4769. Now, I want to take this opportunity to kind of remind you of something. Reminder that all students take calculus. And you might be asking yourself, why is he reminding us of this now? This has nothing to do with this problem, but it actually a little bit does. I want to remind you that everything in the first quadrant is positive. The cosine of any angle from 0 to 90 degrees is a positive value. And the sine is the only thing positive in the second quadrant. So anything from 90 to 180 would give you a negative cosine value. So cosine is positive here, cosine is negative here. So why am I telling you this? Notice what cosine is. Cosine is a negative value. Go back to the last problem. Right here, the cosine was 0.714, which was a positive value. If cosine is positive, now without a calculator, there's no way that you could tell what the angle is, but you can tell this. If cosine right here is a positive value is equal to a positive, you're going to have an acute angle, an angle between 0 and 90. If cosine is a negative value, you're going to have an obtuse angle. And you can see that by looking here, and you might be thinking, well, I can just look at the triangle. You don't always have that triangle. But you should get, if done correctly, you should get an obtuse angle here, an angle between 90 and 180. We mark out cosine by doing the inverse cosine, and we find out that the value of our angle x will be about 118.5 degrees, and you see that it is obtuse. Number 6, and then we'll do some applications. In triangle LMN, LM is 25, MN is 20, LN, and we got problems already. We don't have A, B's, and C's. It doesn't matter because let me show you something. A squared equals B squared plus C squared minus 2BC times the cosine of A. And that's one of the only three formulas we have. So what are we ever going to do? Well, instead of finding measure of angle L, since this is our formula, we'll let this L be A. So everywhere you have an L, we're going to let that be our A's. So in triangle ABC now, instead of LMN, we got ABC. So all of our M's are going to be B's. All of our N's are going to be C's. So there's what you've got now. So now, and that just goes to show you that it doesn't matter, the formula doesn't matter as long as you're keeping everything uniform. So what I've got here, let me draw that. Another way you could have done it, watch this. This actually is going to be a little bit easier. You can take and draw it as triangle LMN. LMN. LM is 25. MN is 20. LN is 24. And you're looking for angle L, which is this angle. Okay, now erase those and say this is A, this is B, this is C. So you can do it like that so that you can use this formula. So if that's the case, you have 20 squared equals B is 24 squared plus 25 squared minus 22 times 24 times 25 times the cosine of that angle A. I want to point out something before I find this angle A. This triangle is just nearly isosceles. So these two, if you were to find these two angles right here, they would nearly be the exact same angle measure, because notice that 25 and 24 are nearly the same. So that means that those two angles there should nearly be the same if we were to find them. So here we go. Let's move our 24 and 25 squared over. So you now have 20 squared minus 24 squared minus 25. What just doesn't want to write right there? Squared equals negative 2 times 24 times 25 times the cosine of A. Wow. My computer is going haywire. There we go. We get rid of this. Since it's being multiplied, we will divide by negative 2 times 24 times 25, and that leaves me with the cosine of A on the right side is equal to, I forgot to unpause there, but it gave me the cosine of A was 0.6675. To undo the cosine, we're going to do the inverse cosine of 0.6675, and that gives me about 48.1 degrees. Okay, now let's do some application problems. And I think we've got 2 or 3 of these. Number 7. Main Street, Oak Drive, and West Avenue intersect to form a triangular piece of land. There we go. The angle formed by Maple and Oak is 79. So we'll call this Maple, we'll call this Oak, and we'll call this West. The angle formed by Maple and Oak is a 79-degree angle. If the Maple Street section of the triangle is 390, and Oak Drive section is 250, what is the length of the west side, West Avenue section? So we have, here's your formula. We'll call this our A, and the other two are B and C. So you have A squared equals B squared plus C squared, and it doesn't matter really which is which. B squared plus C squared minus 2 times B times C times the cosine of 79. Now this one is one that you can just type. Again, if we're looking for the x, we type this whole thing into our calculator, and we have that x squared is equal to about, and it magically appears there, 177,392.2459. And again, to undo the square, we're going to have to square root that, and we'll get approximately x is about 421.2 feet long. Number 8. Jack and Tom start at a tree and begin running apart. So here's the tree, and they're running in opposite directions apart with an angle of 23 degrees between them. If Jack runs 50 meters, we'll say Jack's running this way, Tom runs 38 meters. Find the distance between them now. So we're looking for this distance right here, and it's obvious. Now, something I haven't addressed is why can we not use law of sines on these problems? Well, first off, you don't have an angle and the side across from it. So if you tried to use the law of sines, the sine of 23 over, well, we don't know what that is, equals, that's the only angle we have. So it's impossible. Once you try to use the law of sines, it would be impossible to do that. So this will be our angle A if we want to use that first formula. And we have, this is our unknown that we're looking for. So we have a squared equals, it doesn't matter which one's b and c, but b squared plus c squared minus 2 times b times c times the cosine of the angle 23 degrees. Plug that entire thing into our calculator, and we get x squared is equal to 446.0816, which we find x by taking the square root of that, and that would give us that x is approximately 21.1 meters, is about how much distance you have between the two. And again, notice the reason that SOHCAHTOA will not work there. This is not a right triangle. We can't use Pythagorean theorem. We can't use SOHCAHTOA. Something completely different. Okay, and the last problem, 2 radar stations 2.5 miles apart. So you got, let's skip down on me. You have 2 radar stations. The distance between the two is 2.5 miles, and you got to be careful about units here. Make sure that your units are uniform. If that's going to be 2.5 miles, then everything has to be in miles. They're tracking an airplane. The straight line distance between station A, we'll call this station A, and the plane is 7 miles. So let's say the plane is somewhere over here, so the distance from there to the plane is 7 miles. The straight line distance between station B and the plane is 9 miles. What is the angle of elevation from station B to the plane? So if this is B and you got the plane somewhere up here in the air, we're looking for, okay, here's the 2 stations on the ground. That plane is, if you were to look at it at this angle right here, this is what's called your angle of elevation. From station A, this would be your angle of elevation right here. So it looks like it's going to be closer to station A. So actually this angle, since it's further away from here, this will be a smaller angle. This will be a bigger angle because of the 9 versus the 7. But again, all that doesn't matter right now. We're looking for what is this angle right here, and that's going to be your x. So you plug it into your formula, and if you want to use the b squared formula, it would be b squared equals 2.5 squared plus 9 squared minus 2 times 2.5 times 9 times the cosine of the angle, which is what you're looking for. To solve this, we're going to move our 2.5 squared over by subtracting, and we're going to move our 9 squared over by subtracting. And that's going to equal negative 2 times 2.5 times 9 times the cosine of x. You can move all of this over by dividing. And typing this in is going to give you a decimal, and that's going to give you that the cosine of x is equal to about 0.85. And once you find the inverse cosine of 0.85, that tells you that x is rounded to the nearest degree right at a 32-degree angle.